Hello everyone, welcome back. So in this video we are going to understand the LeetCode problem number 840, magic squares in grid. Okay, so very first let me tell you that what we have given. You are given a 2D grid like this. Okay, so this is a 2D grid of numbers as you can see here, and this is we have given. Okay, and what is your task? Your task is to count how many 3 cross 3 subgrids we have. Okay, inside this grid that are magic square, right? So 3 cross 3 subgrid means what? Means a grid that is magic squares. Okay, and what is the magic square? So it is saying the magic square is a 3 cross 3 grid. Okay, so a 3 cross 3 grid is a magic square if and only if it contains all the numbers from 1 to 9 exactly once, only one time. Okay, so it means what? Means the sum of each row, if you will take sum of each row, if you will take, right, sum of each row if you will take, it should be equal to the sum of each column. Okay, sum of each column, and it should be equal to sum of both diagonal. Sum of both diagonal. Can we say that? So this is what the question is saying. Means if you take the sum of all the what you call the rows, and you will take the sum of all the columns, it is equal. As well as if you're taking the diagonals, it should be equal. Okay, it should be equal. Okay, so this is called, I'm just taking this one, but we have to take the subgrid, right? And it is saying a grid is, what is a grid? A grid is a magic square if and only if all the numbers start from 1 to 9, means all the it contains all the numbers from 1 to 9, right? Exactly once, and sum of each rows is equal to sum of each columns, and it is sum of both diagonals, you can say that, right? So the magic sum must be 15, you can say that. Can we say that? Means if you do the sum plus 1 plus 2 plus it till the 9, it should be equal to 15, right? How? N into n plus 1, right? N is what? Let's suppose 9, and 9 plus 1 is 10 by 2, means 9 into 10 by 2, it is multiplied by 5 times, right? Means 45, right? 9 into 5 is equal to 45. So total it should come, and 45 is 3, we have to divide it 3 cross 3, right? 3 cross 3. So after that it should come what? 15, right? 45 by 3 is 15. So this is what the question is saying that. Okay, I hope you understanding what the question is saying that. Okay, let me recap for you. Very first, what we have given, we have given a 2D grid we have given, and that contains all the numbers, right? And our task is to find the how many 3 cross 3 subgrids we have, right, inside the grid. Okay, and these grids that we are going to find is, these grids are not subgrid, these grids are magic square, you can say, right? This is what the magic square is saying that. Okay, and what is a magic square? So if you are taking 3 cross 3 magic square, right, it means this grid 3 cross 3 will become a magic square only if, yeah, if and only if, right, all contains 1 to 9. All the grid contains 1 to 9 numbers, right, exactly once. Okay, and this is the very first point we can say, and the sum of each rows that we are taking, sum of each rows, right, it should be equal to the sum of all the columns, right? And it should also the sum of both diagonals. Okay, this is what the question saying about the magic square. Also, if the magic sums must be what? 15. How? Why? Because we know that from 1 to 9, if we'll do the sum, right, it will come what? 45. And from there we have to divide by 3. It means it will come what? 15. So this is what the question is saying. Okay, I hope you understand the question. And what you need to do means we have to find how many 3 cross 3 subgrid we have inside the given grid, that are magic squares. So let's understand some example. Okay, if I will write some numbers, let's suppose if I'll say magic number 8 1 6, it gives you what? 15. Then 3 5 is 3 5 is 8. Let's take 7, it gives you 15. Then we can take what? 4 9, 4 9 is 13. We can take 2 more, so you come 15. Okay, if you do this sum, it should be equal to, okay, let's count this, 8 3 and 4, right? 8 3 and 4, 11 4 15. It also gives 40 15. 1 10 and 5 is also 15. 6 7 and 2 and 2, yeah, it's also 15, right? So this gives you 15. Let's go by the diagonal now. Means diagonal, sorry, not this one, this sorry, diagonal numbers are, okay, give me 1 second guys, I'm taking wrong this. Yes, this is called diagonal. Okay, and this is called diagonal. Okay, now take these numbers, 8 5 and 2. 8 and 2 is 10, is also giving 15. 6 5 11 and 4 is also 15. So as you can see, all these numbers are what is giving, all the sum is giving, all the rows, these are the rows sum, these are the column sums, and these two are the diagonal sum. Means everywhere it's coming what? It is coming a 15, right? And so we can say this is called this grid is nothing but a 3 cross 3, guys. And this 3 cross 3 window, or you can say grid, is a magic square. Okay, and if you observe that numbers are 1 to 9 here, exactly once coming, right? So the rows and the column sums are equal, and the diagonal all having the value 15. Okay, means the numbers goes to 15 for all the way. So if the numbers are exactly 1 to 9, we have only ones, and rows sum to 15, columns sum to 15, diagonal sums to 15, right? Means this is a valid one. Okay, so this is a valid magic square, and so this will be counted as a 1. How many? So this count is one magic, this thing, right? How many? So there is only one, we can say one magic square we have here. Like that we have to find all the magic square. So let's suppose if you want to do the what you call solution, right? Very first, think of the sliding window. Okay, so think of it like, let's suppose it's a sliding window of size 3 cross 3. So you start from here. The very first, if you start, that is a 0 0, as you know, right? So this is a 0 0, what you call column grid, we can say. From this cell you will start and check grid, let's suppose 0 to 2 and 0 to 2. Okay, means you will find from 0 1 2. Very first you will check this 3 value, right? So you will also come by the down 3 value, you will check with this, then you will check with this, right? Because if this is a 3 3, so like that you will keep moving ahead, right? It means you have to move right. Okay, the very first you will say, okay, give me 1 second. Very first what you will say, start at start at 0 0 that we have seen here, right? From here, then you will say check grid. You will check the grid how? 0 to 2 we can say, and 0 to 2 means you can start from here, right? These three, then you have to move right. Which side? Move right. So we'll say okay, now move right. How you will move right? Means from 0 0 to 0 1. Okay, and again you will do the same thing, right? Check grid 0 to 2, and this will become, let's say check grid, we will say this time 0 to 2, but this will become what? 1 to 3, right? Means you have to move the right? It means from here to you have to keep moving ahead like this. Okay, and then again you will do the same thing, move down. Once you have moved up, move right. Now you have to move down, right? Very first case, second case, and this is the third case. You have to move down, and once you move down, you will do what? Move row, correct? And you then the third, fourth, you should do what? Repeat these things and keep checking the values. This is what we are going to do now. Okay, also let me tell you about the how the pointer will move, so you can do easily. Let's suppose now that there is 2 pointers we are going to use here, okay, I and j. Okay, so I and j means top left, we can say top left of 3 cross 3 square, we can say that. Can we say that? So very first we'll say I and j we have, right? If we want to come here, it will become what? I and j plus 1. If we want to go down, it will become what? I plus 1 and j will be there only. If we want to come cross here, means I plus 1 and j plus 1. So this is, I'm saying you only for the understanding when you want to move the things, right? It means if we stop when I is equal to or less than equal to, we can say less than equal to rows, right? And this rows is less than equal to what? 3. Rows minus 3, we can say rows minus 3. Row minus 3 is equal to, right? J should be less than what? It should be less than equal to columns minus 3, we can say that. So it will stop. If it is there, it means it will stop. So you have to think about how you will move the grid from II. If you want to come down, you have to use this. If you want to go this, you have to use this. If you want to come here, you have to go this way. Like that, you have to keep moving each cells. Okay, let's think of the what you call intuition, right? How we are going to think. So if you have observed till now, right, what is the key observation we should think about, which is very important, right? Very first, if center must be 5, if center must be 5, let's suppose very first point, right? If center must be 5, we can say it means every 3 cross 3 magic square using 1 to 9 has 5 in center, right? Okay, then this will allow early rejection. Okay, because it is expecting that 5 should be everywhere, right? Means all it should be in the center, we can say that, right? Then only 8 possible magic square exist. So if you do rotation, reflection, right, on one base square, then only 8 possible magic square exist. Then we have, if we'll check all the rows and columns diagonals, which is a cheap and constant time, we can say that. Okay, so what we should do, let's understand high level thing, high level algorithms. Very first, what you will do, take a count is 0. Okay, and for each possible 3x3 grid or subgrid, we can say subgrid, take subgrid. For possible 3 subgrid, right? Very first, you will say if center not equal to 5, right? If center not equal to 5 means continue. Okay, then you will say, okay, numbers are not exactly 1 to 9. If it is not, then continue. Then you will say, okay, if sum are not equal to 15, continue. If columns are not equal to 15, continue. If diagonals is not equal to 15, continue. All these are done. Let's suppose all these are what become the conditions. And after all these condition continues, right, you will just do after this count plus plus. And finally we'll return the count. This is the high level thing that we are going to do, guys. Okay, let me show you the code. Okay, so very first let's understand here. Okay, but very first what we have given rows, we have given columns, we have given, and we have to take the count, right? And we know that we have given 3x3 grid that needs at least 3 rows and 3 columns. So we'll go for all these 3 rows and 3 columns will go, and then we'll stop, right? That we have seen. We'll check if this is a magic grid. So we'll check, okay, to check the magic grid, we'll create this helper function and we'll pass the grid I and j. And if it is a grid, you will say count plus plus, and this count plus plus, we will return it here as we understood. It means we have to create this is magic function, right? So this is magic function we have to create, where we'll pass grid, row and column. So very first, to optimize this, you will take, if it is not equal to 5, so center must be 5. In that case, we'll return what? False. And in other cases, we'll take the scene, means to check the 1 to 9 should be exactly once time, right? So we'll check 1 to 9 appears exactly once, and for that you will make these conditions. You will go for I and j, you will traverse for all the ij, check the value if it is not on the scene, and if it is on the scene, and if it is less than or greater than this, it means it's also out of the boundary conditions, and each grid value you have to put under the scene. And then you will check all the grid sum, column sum, and the diagonal sum here, like this. If everything is perfect, right, you just need to do what? Check the conditions if all those diagonals are also same. So you check all the columns, sum, you have checked the rows, column and diagonals, all are same, means this function will return true. What is the magic function? Is magic grid, and then you will return the answer. This is what we have, guys. I'll put this code into the comment box, you can get from there. And thank you for watching this video. In case if you have any help, let me know in the comment section. And for the structure we are learning, you can join my online classes. Thank you for watching this video. I'll see you in the next one.